Vasundhara and Vishal. You guys are also there. Cool. So I think we have a full house now. We can get started. And I will not ask this question to anybody saying what do you want to learn, because if I say so, Arav will raise hand and tell something which I would not allow. So I will decide what to teach in this class, right? We have a syllabus for this one. I have been sharing this syllabus with everybody's parents. So that is what we will use today. Okay? So in today's class, what I'm trying to teach is, okay, before I move on, do you guys remember what did we learn yesterday? Not Arav. This is not a question for Arav. Nope. What did we learn yesterday? Adrik, you want to go ahead? Quickly.
So we learned like the positive and negatives.
Associations.
Like where the children passed and failed.
Right. So basically we talked about associations in data, positive and negative. Okay. And if I can say that in summary, in brief, we just looked at the extension of scatter plots. Everybody knows what is scatter plot, right? When you're talking about too much of data being represented, it shows a pattern. So just give me 10 seconds, just 10 seconds. That's it. Just 1 second, beta. One small child has left without letting me notice. Just let me check. Okay. Yes, sir. You picked last week, right? Yeah. Okay. No, I just did not notice him. I mean, he just disappeared out for some. Yeah, that's why I was wondering. Okay. All right, sir. Yeah. Thank you. Bye bye. All right. So we talked about what is a scatter plot. How do you understand or interpret the scatter plot to relate that with positive or negative association. So when you talk about scatter plots, you're talking about some data. And then if you see the data plotted going downward, that is called negative association. If you see the data going upward, that is called positive association. Now, a question to Arav. So, how do you interpret positive and negative associations? Just give me a very quick summary of it, okay? I just want to read your interpretation from this.
So basically, we know that if the numbers increase, like you can see that patterns of which dots go in which direction, depending on which of the y-axis, where it goes and where x-axis goes. So basically, you're pointing at which one.
Time out. So, what I was trying to hear from you guys was, when you see positive association, meaning the data, it shows a upward trend, meaning there is a sign of improvement. Earlier, see, if you look at x and y axis data, if your points are here, that means these are not a great performing symptoms of the data. This is where it's getting better. And when you come here, you see the data has improved. When the x is increasing, y is also increasing. It's like you put the effort and you get a score. Okay? If you're putting 5 hours of effort, you're getting better percentage. If you put 8 hours of effort, you're getting even better percentage. So that's the positive side. If it happens this way, you put more effort, your score keeps coming down. That's a negative association. When kids are working hard, everybody is getting lower score. That's a very bad symptom. So that's why it is called negative association. When you see a positive association, you see an upward trend, meaning with more input, there is a higher output. Let's say you put money in your bank and with more money being put, your balance keeps coming down. That's a negative association, meaning you don't want to be associated with the bank because they are ripping off your money. That's why we have to interpret it that way. With one axis increasing, second axis also, if you're increasing the value on the one axis and the value on the other axis decreases, that's a negative association, meaning you would not want to continue with that for long. Okay? Alright. That was yesterday's class. Yeah, Advik, you're saying something?
We also learned about like the and decreasing, like about like the shape.
Yeah. The same thing, negative and positive association, that's what I was talking about. Yeah. Now, yeah, Arif?
Are we also going to learn the scatter plot that goes to
That I will decide. That I will decide. Stop it there.
Okay.
Stop it there. Okay. So I have chosen 2 topics. Okay, and you guys have to tell me which one you want to follow. And that option is not for people who talk more. That's only for people who talk less. Meaning only people with less noise will be given the opportunity to speak. One topic is talking about exponents, rational exponents. Exponents, rational and radical exponents. That is one topic. Second topic is, we talked about similarity of triangles, right? Second is proving the Pythagorean theorem. So Arab doesn't have a chance to choose the topic, because and the reason why I'm saying so, because he has probably seen the Pythagorean theorem. How do we prove that he has seen before? So anybody else, let's say Vishal Vasundara, which topic you would want to choose? Exponents, radical exponents, rational exponents, or proving Pythagorean theorem?
Radical exponents.
Okay. So exponents, radical and rational exponents. That's what you would want, Vishal? Okay.
Yeah.
Okay. Anirudh, are you okay with that? Dikshita, are you fine with radical rational exponents?
Yeah. Yes, sir.
How about you, Vivan? Are you okay with that? Not okay? No, you unmute yourself and say it. I want to hear you.
No.
What do you mean by no? You know it, you don't know it, or you don't want to learn it?
I don't want to learn it.
Why so?
I don't know.
Okay, then that choice is not given. If you start eliminating your learning opportunities, can I put it this way? Do you know what is a rational exponent? No, Arif, I will ask you when I need to ask you, okay? I'll not ask you for wasting everybody's time. Yeah, Vivan, do you know what is a rational exponent?
I think it's like an exponent which has like decimals or fractions in it.
Okay, and can you solve something that if I give it to you? Because,
No.
see, what is that?
I can't solve it.
You can't solve it, then you have no other choice but to learn it. Yeah? Let's learn it, okay? I mean, I would not say no to learning opportunity, because if we start choosing what we want to learn, then we'll only learn limited number of things, right? Yeah? Is that okay? Okay. It's a Sunday evening, you don't have much choice what to do. Yeah? Okay. Alright. So we are going to learn exponents, rational exponents and radical exponents. And trust me, Arav, I will give you opportunity to ask questions. I will ask you question, but you are not the only one who can ask the question. So keep it under control, okay? Stay calm, take a deep breath. Don't rush for it, okay? Alright. Everybody knows what is exponent. Everybody, right? Bhupal, clear?
Yeah.
This is an exponent where you have a power to a number or a variable. This is also an exponent. This is also an exponent. I have a number, I have a power to it. This part everybody knows. Now, I'll do some quick fire, okay? And only answer me crisp, to the point. No taking me around, okay? Here, if I have x squared multiplied by x cubed, how much that will be, Dikshita?
X6.
X to the power 6 Arab, you cannot unmute yourself. Control your emotions. Nobody goes crazy or mad. Okay, I will ask. Tanu, how much it will be?
X plus 2 plus 3.
So x to the power 2 plus 3. That will be x to the power 5. And I must thank Tanu for saying it that way. Tanu could have told me x to the power 5. That would have been a point blank answer. I don't like point blank answer. I need the process part of it. So when you say x to the power 2 multiplied by x to the power 3 equals x to the power 2 plus 3, whether 2 plus 3 is 5 or 7, I don't care. Okay? As long as you say x to the power 2 plus 3, I get convinced that okay, you are careful about the process part of it. Okay? Okay? Now, if I do this, if I go to the next step, again, everybody knowing the exponents might be laughing at me right now, saying, okay, you are talking about the kids' play. But hold your emotions for a little bit more. X to the power 4 multiplied by x to the power 6 multiplied by x to the power 2. How much that will be, Araf?
It will be x to the power of 12 because there's 3-digit numbers and you're.
No, wait. You have to start cutting down on the waste of time. What did I ask? X to the power 4 multiplied by x to the power 6 multiplied by x to the power 2. Now let me give you an example. Your answer is right, but wasted time is not good. It will be x to the power 6 plus 4 plus 2, which is x to the power 12. That's it, done. 30-second deal. Okay? Don't go beyond that. Now, because see, time is the essence, time is the most crucial part. You get an SAT exam or any exam, you have 20 questions. You write Ramayana, Mahabharata, Bhagavad Gita for 2 hours. You have only one question solved. So make sure you are cutting down on the waste of time. Okay. Now, x to the power 6 multiplied by x to the power 8 divided by x to the power 3. How much that will be, Bhupal?
Wait, what?
X to the power 6 multiplied by x to the power 8 divided by x to the power 3. Everybody keeps doing it. Keep it ready. I will ask whom I have to ask.
Wait, what are we doing again?
We have x to the power 6 multiplied by x to the power 8 divided by x to the power 3. Vasundhara, can you try answering that one while Bhupal is trying it? Vasundhara or Myra? One of you. All the kids who are sleeping needs to wake up.
I got x to the power 11.
X to the power 11, 6. Okay, how did you get that? Vasundhara, you have to explain me, okay? No, I'll tell you better, okay? But when I ask this question, okay? I want you to explain it to me. Yeah.
6 plus 8
Uh-huh.
and then divided by
X power 3. Right.
Okay, I get it now.
Yeah.
minus x to the power 3.
Yeah. So basically, yeah, the deal here is when you have multiplication happening with the exponents, the power gets added. When the division is happening, the power gets subtracted. So what did you do? You looked at the numerator and you got x to the power 6 plus 8, and then you looked at the denominator. So now it's like it became x to the power 14 divided by x to the power 3. Now when you have x to the power a divided by x to the power b, it becomes x to the power a minus b. Yeah? That's what you did, Vasundhara, right? Because you got the right answer.
Yes.
Okay. So here, what I'm trying to repeat myself, why I'm trying to repeat myself is this. When I'm doing multiplication of exponents, the power gets added. When I'm doing division of exponent, the power gets subtracted. So you do in 2 steps. You did addition first. You are taking care of the numerator. Then this is your denominator. Then you know when you are dividing it, this is what happens. Subtract. Now, this is just the recap part of it. Okay, this one last thing I will do, and then we will start seeing the fun with the rational exponents. And everybody, when I call out your names, be ready, okay? Because I would not call anybody to dance, so stop dancing. I will only call you guys to solve the problem, which needs you to be in a very balanced frame of mind, very stable, okay? This is, there are a lot of art of living classes, right? So I don't do art of living, I don't believe in that at all. But then there's the basics of living that we all need to know. Alright, coming back to this. If I have x to the power 3 to the power 2, how much is that? But Adam, hold it. Let me go to Sagnika.
Is it x to the power of 6?
How?
Because I times. Wait, never mind. X to the power of 9.
No. You were right with your first attempt. Okay. Let's make it simple. Okay. It's always when you have x to the power a to the power b, it becomes x to the power a into b. Why? Because when you have this, right? What it will break down to? It will become x to the power 3 multiplied by x to the power 3. Correct?
Yeah, but I did 3 times 3.
So you will not do 3 times 3. You will do 3 times 3 plus 3 because it's a multiplication of exponents which adds the power. Correct?
Yeah, I get it now.
Yep. So now let's add more fun element to what we did. So there are 3 rules. Multiplication of exponents adds the power. Division of exponents subtracts the power. And exponents inside the bracket to power that multiplies the power. Now x to the power 1 by 3 multiplied by x to the power 2 by 3. Who will solve this and tell me? No, Adam, I solve it. Be ready. Do it on a piece of paper. Raise your hand. Yeah. Yes, Sanvi.
It's x to the power of 1 or just x because because 1/3 plus 2/3 is 1.
Right. So this is the same thing. Here you have an exponent. Here you have an exponent. When you are multiplying the exponents which have the same base, you add the powers. So it becomes x to the power 1 by 3 plus 2 by 3. And when you add them, like a normal fraction addition, this is what becomes. Right? Now, so this is called rational exponents. So let's do a few more sums and then we'll go to the next part. So let's say if I give you 3 to the power 4 by 9 multiplied by 3 to the power 2 by 8 multiplied by 9 to the power 1 by 6. Who all can solve it? Solve it and then raise your hand. And I would want everybody in the class to try it, okay? It's okay if you make mistakes, but not trying is not acceptable. If you have finished it, spend some time to review it. Don't rush and make mistakes.
What theory? So, you know the 4 over... I don't get this.
4 over 9.
Yeah.
3, 4 over 9. 3, 2 over 8. And 9, 1 over 6. So, Bhuvan, I would certainly want to hear your answer as well, because I have been bothering everybody. I haven't reached you yet. Okay? I mean, bothering meaning I have to pay attention to each one of you, right? So, to just make sure that everybody learns and applies that. So, Bhuvan, I will certainly come to you, okay? Anybody being done can raise your hand. But whoever raises the hand cannot go wrong. Meaning you have reviewed it. Okay, Sanvi. Oh, okay. Let me. I'll come to you, Sami. Okay. Let's see, Advik. What is your answer? And how did you do
So I
it?
don't want to skip to the answer just yet, but what I did is that I did 3 times 3 times 9, which got me 81. And then I times all the fractions together.
3 times 9. No. Say it one more time.
Oh, wait, never mind. So wait, what I did was that I added the fractions. Since multiplication is equal to addition. And then I reduced 9 1 by 16 to 3.
It's 1 by 6.
Oh.
I think you're going the right direction, but just can you solve it one more time? I mean, just it's 3 4 over 9, 3 2 over 8, and 9 1 over 6. Just check it once. Yeah, Sanvi. Let me see what Sanvi has to share.
I added the fractions and I got 62 over 72 because they're all like factors of 72. Because 9 times 8 is 72, 8 times 9 is 72, and 6 times 12 is 72.
Okay.
And then
So what
I
did
multiplied the bases, so I got 81 to the power of 62 over 72.
This is your final answer?
Yeah.
Okay, let's see what everybody else is going to share. Yeah, Myra, how much did you get?
So I got 81 and 31 over 36 because
81, 31 over 36?
I added all the fractions together and I got 31 over 36 with simplifying. Then I multiplied 3 times 9 and I got my answer. And then I multiplied 3 times 9 and then I got 81. Then I did 81 to the power of 31 over 36.
See, I will not discourage anybody in the class saying that you guys got a wrong answer, but based on whatever I've heard so far, I've not found anything convincing enough. Okay, it was a bit of a trick question. Okay, a little bit of trick. When I said trick, it was not actually a trick. I was trying to apply 2 of the exponents rules in one problem. Okay, when I will try solving it, because I don't trust any of you, I will solve it myself. But when I try solving it, you will see where you guys are going wrong. Okay, everyone, any luck with what you have tried so far?
No, I got the same answer.
Same answer is 81, 31 over 36 or 81, 62 over 72?
They're the same, aren't they? They just simplified.
Okay.
Yeah, I got 81.
Okay. How about Vishal, Vasundhara?
I got like 9 to the power of like 36 to 37 or something like that.
Okay.
Around that.
That is interesting. We are getting more diverse answers. Very nice. How about you, Tisha?
I was like still kind of working on it.
Okay. Once you're done, let me know. Okay. Bhupal, you want to share something?
Well, I'm still working on it. I'm almost done though.
Okay. How about you, Pranav? How much did you get?
I got 81 by 7 23.
7 by 23. 81 to the power 7 by 23. That's what you're saying?
Yeah.
Okay. How about you, Arav?
I got 81 by 50 by 72.
So it's called 81 to the power 51 by 72. Okay. Now, okay. So let me stay firm on my statement. I don't trust anybody. And again, I would want you guys to stay firm on that as well. Don't trust anybody. I don't know which one is the right answer. I will do it myself. Okay? But I would want you guys to watch me carefully. Very carefully, okay? Vivan, any luck with your answer, beta? What did you get? Vivan, you're talking on mute. I cannot hear you.
I didn't do it yet.
Okay. Are you doing it?
Yeah.
Okay. But just in the interest of time, let me try doing it, okay? Because I cannot just assign tasks to you guys and I don't do it myself. Let's look at what will I do if I am in your place. I have 3 to the power 4 by 9, 3 to the power 2 by 8 and 9 to the power 1 by 6. That is what gets me worried. I have two numbers with the same base, two exponents with the same base, but this guy is an outlier.
Can I fix my...
Yeah. Yeah, Vishal. Vishal, tell me. Unmute yourself and tell. Vishal, you're talking on mute probably. You have raised your hand, but you're not saying anything.
36 by 7.
No, I could not hear you completely. Can you repeat? Can you type it, Vishal? Okay. Once he joins, he will share. Okay. So, but here the thing is, if I am trying to solve it, first thing that will catch my attention would be this. This and this are fine. Same base. These are two exponents, rational exponents, same base. Yeah, Vishal, you have joined back?
I got 3 to the power of like 27 by 36.
Okay. This is another unique answer. So let's see. I mean, I don't know who to be friend with. So let me try finding out my answer and then I'll find probably one of my best friend in the class. Okay, I'm just kidding. Everybody is equally close to me. I'm just putting some bad dad jokes. That's what Myra says. Okay. All right. So here, when I look at this number, I see this and this are same, having same base. So when I'm dealing with the exponents with the same base, my life is easier. Here's the complication. I have 9, meaning a different base. Can I convert 9 into base of 3? Yes, I can. So first thing I will do is, before I try solving it, I will try simplifying it. I will not say 9, I will say 3 to the power 2, 1 by 6. Now life is getting little better. Because now if I look at this, I have this has 3 base, this with 3 base, this also with 3 base now. Only problem I have to knock off is get rid of this bracket. And that is where this remains 4 by 9. See, if you look at how I solve problems, I don't rush, I don't jump. Because beauty lies in simplicity. Keep it simple. Okay? Now, this is x to the power a to the power b form. It becomes x to the power a into b. This is what this will become. So this will become 3 to the power 2 multiplied by 1 by 6. Yeah, Vishal.
I meant to say 3 to the power 36 by 37.
36 by 37? Okay, we'll see. So now, this guy became, now this becomes, we can do tic-tac-toe, so this becomes 1 by 3. So now I have 3 to the power 4 by 9 multiplied by 3 to the power 2 by 8 multiplied by 3 to the power 1 by 3. It's a simple exponent multiplication. So this becomes 3 to the power 4 by 9 plus 2 by 8 plus 1 by 3. Just add this, that is your final answer. So now if I add 4 by 9 plus 2 by 8. 2 by 8 is nothing but 1 by 4 plus 1 by 3. What is the LCM for 9, 4, 3? 36. 9 4 is 36, 4 times 4 plus 4 9 is 36 into 1 plus 3 12 is 36 into 1. So it becomes 4 4 is 16 plus 9 25 plus 12. 25 plus 12 37 by 36. So the answer 3 to the power 37 by 36 is the right answer. And there was nothing complicated about this whole problem. Only thing that we had to take care of was catch the problem area sooner than later. This was the problem area. These two had same base, these had a different base. So first thing was simplify it. How do you simplify it? Make everything with the same base. That is when life becomes easier. How do you convert 9 into 3 base? 9 is nothing but 3 square. Now you have all same base. Then you can play around with it. Yep. So yeah, Vishal, you got the right answer. And I'm pretty sure you...
I did the fraction part wrong. I like flipped it instead of 37 by 36, I said 36 by 37.
Right. No, I mean, that's where you kind of flipped your answer. Yep. So let's go to Anirudh. What was your answer, Anirudh?
3 to the power of 37 over 36, isn't that supposed to be 4 to the power? Wait, no, is that how it works?
No, it doesn't work that way.
Actually, never mind.
So this is where you will stop actually. So 3 to the power 37 by 36. That is where you will stop. Because there is no more calculation that you can do by yourself. You have to lean on a calculator to find it. But as long as you get to this point, you are covered. Yadvik.
Can I go to the bathroom?
Uh-oh. No. You can go ahead. You don't have to ask for it, okay? You can just send a message and go. Okay? Alright. Yeah, Anirudh, you had a question?
Never mind, my hand was up.
That's okay. So, here, what did we see was that when we have a complex looking problem, you have to look at finding ways to simplify. Where I found some of you going wrong was this. You said, I have this power, I will multiply 3 times 9, that makes it 981, and then I add the power. No, never ever do that. That's a crime. That's not a mistake. That totally defies the basic rule of exponents, multiplication, addition, and subtract, and a power thing. When you have x to the power 2 multiplied by x to the power 3 multiplied by x to the power 4, what do you say? You don't say x into x becomes x cubed to the power 2 plus 3 plus 4. No, you don't do that. So never multiply these things. When you're dealing with exponents, make sure that you have the same base and then you add or subtract the power depending on whether you're multiplying it or dividing it. Okay? And same rule. The good thing is, same rule applies for exponents with power as a natural number or exponents with power as a rational number. Okay? Are you guys with me so far? Everybody? Vivan, are you okay with what we did? And see, my main job is to make things interesting, which is sounding boring to you guys, right? So Vivan was saying, "Oh, I don't want to learn. There's not something exciting enough." But now, after whatever we have done, do you think we learned something, or it was still a waste of time?
I think I learned something.
Very nice. My job is done. All right. But yeah, I mean, did we learn in a way that it stays with us, or did we learn it just for the sake of compliance? Stays with you, right? Okay.
Yeah.
Cool. All right. So let's muddle the water a little more. Now, careful, okay? Whatever we have done, I'm not going to do anything magical. I just want you guys to be a little more careful, okay? Math is all about practice and fun. Who all is going to solve it quickly? So, normal exponents, rational exponents is what we are doing, and then comes radical exponent, which we'll talk about after we solve this problem. So, we have only 5 minutes to solve this problem maximum, okay? 4 to the power 2 by 8 multiplied by 2 to the power 6 by 9 divided by 4 to the power 1 by 6. And I can guarantee there's no new concept needed. Whatever we have done so far, if you guys pay attention to it, you should be able to solve this in less than a minute or maximum 2 minutes.
What's the bottom say? I can't read it.
It's 4 to the power 1 by 6.
Okay.
Is it easy to read now? 4 to the power 1 by 6. Yep. Okay. Arav, have you completed it already?
Yeah.
How much is the answer? Just tell me the answer for now. And
I got
Uh-huh.
315 by 432.
Is this the answer?
Yeah.
What is the base?
Oh, my mistake.
Okay, Advik, what did you get?
2 by the power of 5 by 6.
Okay. Okay, let's see. Just, okay, I'll be back. Yes, sir. Hello? 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 All right. How much did you get, Dikshita?
I got 4 to the power of 4.
To the power of?
4 to the power of 7 by 11.
7 by 11. 7, 11. Okay. Let's see what Pranav got.
I got 2 to the power of 5 by 6.
Okay. So one extra vote for 2 to the power 5 by 6. Okay. Let's see what Myra got.
I got 2 to the power 5 by 6.
Okay. What did Arav get?
I just got 11. I got 2 11 by 18.
2 to the power 11 by 18. Okay. Okay. Vivan, Vishal, Vasundhara. Vivan got same answer as which one?
I'm just rechecking my work.
Okay. Two to the power 5 by 6. Okay. Okay. How about you, Thanu?
Still working.
Okay. How about Tisha?
2 to the power of 5 by 6.
Okay. Dikshita, you told your answer. Where is Sagnika? Sanvi, what was your answer? 2 to the power 5 by 6. How about you, everyone?
I'm still.
You're still working on it?
I'm checking.
Okay. No, and always remember this. Whenever you solve a problem and you believe that you have already solved it, there is no harm in spending 30 more seconds and doing a quick review of what you have done, because that 30 seconds could probably help you score more, because many times we make mistakes without knowing about it. So even if you know the concept, you applied it, one small mistake while calculating could really go wrong. Okay? Alright. Adam, you have already told the answer, right? Put your hands down.
Oh, sorry, I didn't know.
Yeah. No, I'm just checking. Okay. Alright. Whoever is still working on it can probably work on it, but again, same approach. Let me try solving it for you guys. Here I have 4 to the power 2 by 8. Here I have 2 to the power 6 by 9. 4 to the power 1 by 6. Again, I see different bases. Here these two have the same base, but this is a different base. Whenever you come across this scenario, your first attempt should be to make it all as the same base. And ideally what you should do is convert a bigger number into a smaller base. Because you know 4 is nothing but 2 squared. 2 is square root of 4, but there is a complication, that brings complication into the mix, right? But 4 you can always convert into 2 square. So let's do that. 4 I will write as 2 square. Whatever is on the top of 4, 2 by 8, multiplied by 2 to the power 6 by 9, by 4 to the power 1 by 6. So 4 again I will write as 2 square to the power 1 by 6. Now, always look for simplifying things. Yeah, Vishal, what was your answer?
I got 2 to the power of 5 by 4.
5 by 4, okay, let's see. Now, here, 2 by 8. 2 by 8 you can always simplify as 1 by 4. So I did not change anything, just 2 by 8 I converted to 1 by 4. 6 by 9, same way. If you want to do tic-tac-toe, 6 by 9. 6 is 3 into 2, 9 is 3 into 3. So 6 by 9 is equal to 2 by 3. So you can also convert this into 2 by 3. I'm just trying to make them simple, smaller, so that it's easy and under control. Now, you have 2 to the power 2 to the power 1 by 4. So it's x to the power a in bracket to the power b. It becomes x to the power a times b. So 2 times b, 1 by 4, into 2 to the power 2 by 3. That remains as is. Divided by 2 to the power 2 multiplied by 1 by 6. That is when you break the bracket, you multiply. When you simply multiply, you add. So this became 2 to the power 1 by 2 multiplied by 2 to the power 2 by 3 divided by 2 to the power 1 by 3. 2 times 3, 6. 2 to the power 1 by 3. Now you have 2 to the power 1 by 2 and 1 by 3. So you will add this 1 by 2 plus 2 by 3 divided by 2 to the power 1 by 3. So this becomes 1 by 2 plus 2 by 3. This gives 6, 2 times 3 plus 2 into 2. So this becomes 7, 3 plus 4, 7 by 6. So this part alone became 2 to the power 7 by 6 divided by 2 to the power 1 by 3. This is nothing but division. So this will subtract the power. Both have same base. So it becomes 7 by 6 minus 1 by 3. Now you do this math. 7 by 6 minus 1 by 3. LCM is 6. 1 times 7 minus 2. 5 by 6. So it became 2 to the power 5 by 6. If you look at the whole thing, what did I do? I had numbers with different bases. I looked at converting them into a smaller base.
Wait, so for the second, you said 4 to the power 2 by 8 times 2 to the power of 6, but that's 6 by 9?
Yeah, this is 6 by 9. 6 by 9 becomes 2 by 3.
I thought it was 6 by 5.
Oh, okay. Maybe that is where your answer did not match. But
Like,
yeah.
it looked kind of like 5.
Yeah. No, that's okay. I mean, see, again, we don't really have to worry about the answer part of it. As long as the process or the alignment for solving the problem is correct, the chances of going wrong is less. So that's what I was saying. When you look at this question like this, your first thought process should be, okay, I have numbers with different bases. How do I make them uniform? Make the bases same. And you would not want to increase a smaller number to a bigger number as a base. You will always see 4 as a 2 square versus looking at 2 as a square root of 4. Okay? So when you bring them all to a smaller base, all 4 becomes 2 square, then your life is much easier. These are the same basic rule of exponents. So when you try solving these kind of problems, you don't really have to worry about the complication around the solution. It's about how do you approach it, how do you think about different stages, how do you eliminate what you don't like to solve, right? Again, if I have to keep solving with different numbers as a base, I'm not learning anywhere. If I make the bases same, I have a better chance of getting control of the whole thing. So that is what should be your approach. So the kids who have joined recently, I have an opportunity to bore everybody with my one concept called plan. Okay? I always say, don't jump to solve a problem. Put your thoughts around it first. That's what this concept is. T is trust. Every problem anybody in the world can solve, that is you. So always trust yourself. Keep that trust deeply rooted in yourself. Okay? So don't have to use T for every problem. That is your personality. That if there's a problem to solve, I can solve it. Then comes R. R stands for read. Read the question again and again. For many of you, whoever went wrong, why you went wrong? Because you probably could not see the question correctly. So that is where reading the question is very important. Read the question again and again till you get tired. And once you read it enough, then you would know how to go about solving it. Reading the question enough makes the problem easier, trust me. Then analyze. That is what I was saying. When you look at the question, think about it, okay. I have different numbers, different bases. How do I simplify them? How do I make them uniform? And then approach. So that is where the analysis comes into play. Once you have read the question, you have understood what the problem is, what is being asked to solve, then you analyze, you put your thoughts together, saying, okay, this is how I'm going to solve it. That's what A stands for. And N is something I am not paid for. N stands for Nike, which says just do it. So, STRAND is what I call it. Trust yourself, read the question enough, analyze before you try doing it. If I can summarize that. So, biggest mistake we commit while solving a problem is we straight away jump onto the problem. If you don't put your thoughts together, if you don't read the question enough, solving it may or may not be right. Alright? So, for Anirudh and Vishal and Vasundhara, I know this is new for you, but everybody else in the classroom has heard it so many times that they are sick of it. Literally, they are sick of it. And I want them to be sick of it because I want this to be part of your behavior. When you have a question, don't jump onto it. That's what I'm trying to say loud and clear. If you get a question and you start solving it, there's a very high likelihood of you going wrong. Okay? Alright. Any doubts with respect to what we have learned for basic exponents or we did revision of exponents and the rules, and then the rational exponents? Any questions so far? I assume no?
No, sir.
Okay. Now let's add more fun to it. We have 10 more minutes. Let's learn something. I said 3 terms: exponents, rational exponents, and radical exponents. What is a radical exponent? Who knows? Yeah, Vishal.
Exponent using the roots.
Using the roots, okay?
Like square roots and cube roots.
Okay. How about you, Arif? What is your definition of radical exponents?
The rational?
Radical.
I think it has to do something with like square roots or like under roots or like something that has to do with
Better use of time. Stop it there. Alright. I will put it differently. I will say, Yadvik, one last answer and then I'll move on. Yeah.
It's in the name. It's radical and it's an exponent.
And you might be very smart, I am not. How do you define it?
I'm none of that part.
Okay, then, so, okay, that's why devil lies in the detail. If you have to explain something, you have to get to the detail of it. Yeah? Now, I will put it differently. There is no we don't need to learn about radical exponents. You guys already know about it. Okay? It is just a different representation. Like what Vishal and Arav were saying, it has something to do with square root. We actually already know about it. When I was talking about 3 to the power 1 by 2 or 1 by 3, this by 3 that you see here, that is nothing but the cube root. If you see 3 to the power 3, this is cube of 3. If you see 3 to the power 1 by 3, this is cube root of 3. Or if you see 1 by 2, this is square root of 3. If you see this is the fourth root of 3. And you can represent that in a different way. You can say square root of 3. This is the radical exponent. So radical exponent is nothing but a different representation, if you can say so. Okay? You already know rational exponents. This is same as 3 to the power 1 by 2. If I say 7 fourth root, this is nothing but same as 7 to the power 1 by 4. So this is called rational exponent and this is called radical exponent. Two different representations. Does it make sense? Vishal, Anirudh, Bhupal, I'll just call out random names, okay? I have no intent. Tisha, with me? Okay, cool. So, radical exponents should not trouble us. It is just a different representation. Stop playing with the emojis. We had enough emojis on the screen. And I'll show you guys some magic. If I put two fingers here, it throws balloons on the screen. See, that is stupid AI. AI is nothing but stupid, okay? Alright, so...
No, ChatGPT is better.
Arav, I did not need the expert comment. I just said stupid because it was distracting me. Anything that distracts is stupid. Okay? Alright. So, I said radical exponents and rational exponents are the same stuff. Advik, don't play with it, brother. You can play with it later. So, radical and rational exponents are the same. Only difference being they are different representations. Now, you will say, can I represent a rational exponent like a radical exponent? Answer is yes. If you have 7 to the power 4 by 9, what does it mean? What is there in the denominator? 9. That is nothing but the 9th root of 7. 9th root of what? Of 7 to the power 4. That's how you can break it down. I have 7 to the power 4 by 9. Whatever I had in the denominator, that is the root. Rest all is a number. Okay? Is that an overdose of information? Or easy to digest?
This is the best information ever.
Wow, I'm about to fall on the floor now. Just give me 10 more seconds. Okay. But yeah, see, this is a normal human behavior. You praise somebody, that person feels happy about it. You don't have to do that here in the classroom, but yeah, this is something that you have to learn for your future. You have to learn how to still make people feel happy. Anyways, coming back to this one. Radical exponents, no fun, nothing different. Whatever you learn with rational exponents, just a different representation. You can interpret that in different ways. If it's me, if somebody says 4 to the power 5 cube root, I will treat this thing as a bracket. Because what I will do, I will make this 4 to the power 5, 1 by 3. See, I am treating this radical sign as a bracket and we'll do the same stuff. Yep. So I'm replacing this with a bracket 1 by this. Yep. Who all are tired? Everybody.
I am not tired. The math is the best.
Okay. So yeah, that brings us to the end of the class. We learned about the exponents, rational exponents, radical exponents, and some of the basic concepts that we need to apply while solving the problems. Okay, hold it, Vivan, hold it there. So I'm just doing a recap and I'll let you guys go. Okay. So we learned about the radical exponents, rational exponents. How do you relate them? Radical exponents are nothing different, just a different representation of rational exponents. And then we learned some of the basic tricks which you can apply and use while solving the problems. Okay. So some of the new kids in the class, Vasundhara, Vishal, Anirudh. Just a quick question for you guys. Are you able to keep pace with the way I speak or you're still catching up?
Yeah.
Okay?
Yes.
Speed is okay? Okay. Everybody else is anyways used to bearing with me. So they have anyways caught up with my speed and I have caught up with their speed as well. Yeah? Alright, so that brings us to the end of the class. I'll let you guys go. Enjoy the rest of your evening. Wait for the assignment. I'll publish the assignment in this group. I would want you all to solve the problems and show it to your parents as if you are explaining them. Because when you do that, you will realize where you still have doubt and what all you have understood well. If you have understood something very well, you'll be able to explain that to your parents. So that's why we do it. Like, I don't check your assignments. I ask you guys to get your assignments checked by your parents. Meaning you give it to them and you explain them as if you are teaching them. Okay? Alright? Enjoy the rest of the evening. See you guys on next Saturday. Wait for the assignments.
Bye.
Alright, bye-bye. Take care.
Bye.
Bye-bye. Bye-bye. I see kids flying. See you guys next Saturday.
Teacher, I thought we were gonna learn about algebra today. Because I was in my math book, I was learning about two variable equations with exponents and with fractions.
You give me.
Are we gonna learn at some point of time?
आराम से इतना जल्दी बोलोगे तो I will not be able to follow you. Okay, so whatever we have to learn, you have to send me a message because you anyways know how to reach out to me. You send me in advance